Hi, 8th graders. This is a little intro to your lesson that you're going to be doing today. I am filming this so that way you can sort of know what is happening in class today and get a little sense of what you need to do. To start, I am in your book on page 30, and I'm also going to have out a lab sheet that looks like this. So a lab sheet in your packet that looks like this. I want you to find those two things. If you need to, pause this video right now so you can find those two things. You need this lab sheet that has these images on it, so find that. I think it's probably page 6 or 7 in your lab sheet, or in your lab packet, or in your packet. And then your book, you should have it open right now to page 30. All right, so transformations and congruence. We've already studied transformations quite a bit. Those are reflections, rotations, and translations. Congruence, however, we have not really talked about very much. And we're going to be talking about that a whole lot this lesson and the next lesson. So transformations and congruence, that's what we're going to be focusing on. You can use reflections, rotations, and translations to arrange copies of a basic design element, so a pre-image, into a symmetric pattern, as the kaleidoscope patterns show below. So we have these different kaleidoscope patterns. And I want you to ask yourself, can you find the basic design element in each of these patterns? Can you see the thing that is repeated over and over? Is it just one of these triangles, or do you need two of them? Do you need an entire half of it to make this thing look like it's reflected or rotated or whatever? Then what transformation could you actually use on that basic design element to make this symmetric pattern? So if I were to look at this one, the rotation, translation, reflection that I need to do for this one is likely going to be different than it is going to be for this one or this one. I want you to identify what those are. Next, two figures that have the same size and shape are congruent. So the idea of congruency means that you have something where if we are to look at the sides of it, those sides would all need to have the same length, and then they have the same shape, meaning the angles are also all congruent to the angles on another shape. So as we can say essentially like these two shapes are congruent. If I were to just look at the outside shape of both of these, they are definitely congruent. If I were to look at the inside design of these, they are definitely not congruent. So we'll have to look and see what aspects of this we actually need to pay attention to. If you can flip, turn, or slide one figure exactly onto another, the figures must be congruent. So that's a way that we can prove congruency. That's a very key idea here. We are going to be proving congruence through rotations, reflections, and translations. Okay, those three things are the way that we're going to prove that something is congruent. In this investigation, you'll compare the size and shape of geometric figures after a sequence of transformations. So we're now not just going and sliding a shape over. We're not just flipping a shape over. We're not just rotating a shape. We are doing all of those things at once. So I might rotate a shape, then slide it up, and then reflect it, or whatever it may be. You might be seeing multiple transformations that occur between today and tomorrow. So 2.1, that's what we're working on today. I'm now on page 31 of our book. When two polygons are congruent, you can match the vertices in a way that the pairs and angles of the same are vertices in a way that pairs of sides and angles of the same size. Quadrilaterals ABCD, so this shape ABCD, and PQRS are congruent. So they're saying that these two shapes are congruent because we can slide, rotate, reflect these shapes so that way the various angles are meeting up and they're corresponding. What are the pairs of congruent sides and angles? So if I'm looking at these two shapes, I should be able to identify some congruent sides or angles. So I can say like side AB is congruent to side RS, right? Those two sides are our second longest sides on here, and they are the same length. Same angles. What are the congruent angles? I can say angle B or angle A is congruent to angle R. Angle B is congruent to angle S. Now we need to ask ourselves, how can I move this shape ABCD onto this shape PQRS. And if you're doing this, I want you to use a piece of patty paper to sort of make that happen. See if you can figure it out. So if you can figure out how this shape moves onto this one, whether it be a translation, a reflection, or a rotation. Maybe it's a reflection and a rotation. Maybe it's a rotation and a translation. Maybe it's just a rotation. Maybe it's just a translation. Figure out what you need to do to make this shape move onto this shape and be exactly lined up with its corresponding points. After you have done that, you're going to start making some statements in terms of corresponding and congruence. So some information that I want you to be aware of. We can show that an angle is corresponding. So we can say angle A corresponds to angle R in this case. This is how we can write that statement. So if I were to actually like translate this out into actual English words, I'd say angle A corresponds to angle R. So some words, some symbols that I need. Angle is here, so it's that little like, it almost looks like that Pac-Man sign that we use for less than. And then corresponds to is that arrow. Okay, so that's some math information or some math language that you need in terms of geometry. Now we also have some other math language for geometry that we're going to be looking at, and that's to describe things like side lengths. So side length AB, I would write like this. So AB tells me the vertices that I'm looking at in terms of this side length, but this bar on top specifically tells me I'm looking at the side length that, or side length, I can spell, side length that has A and B as its corners. Okay, side length AB is a length of line that has A and B as its corners. Okay, so it's side length AB, and I can say this corresponds to side length RS. Okay, oops, that's nice and blurry. All right, so to look at this some more, AB corresponds to RS. Now pay attention to this as well. A is the start of the alphabet here, but AB is the line I'm focusing on. But this shape over here is PQRS, like that. But the corresponding side is RS. So it's partway through our alphabet understanding of this name here to get the same corresponding side. So understand that your final congruence statement that you may end up making, which is something that you'll be doing in question, let me see, question D, number 2. When you're doing that, you're going to have to pay attention to what corresponding sides A, B, C, D refer to in terms of this second shape, because your final answer will likely not be A, B, C, D is congruent to PQRS, because that will be a false statement. Last but not least, you are going to see this symbol. Okay, 2 lines that look like an equal sign with a little squiggly on top. This symbol means congruent. In the past, you have maybe seen this symbol right here. This symbol means similar. We are not going to be making similarity statements. We're going to be making congruence statements. So when I say congruence statements, we know that side length AB corresponds to side length RS. That means we can make the congruence statement because we know A and B, when we line them up onto RS, when you figured out what your translation or transformation needed to be to get PQRS underneath ABCD, AB then we can say is congruent to, not CD, RS. So we can now make congruent statements. AB is congruent to RS. And that's how I would say that. I'd say side AB is congruent to side RS as my final statement there. I can also say things like angle A is congruent to angle R. So I can write angle A is congruent to angle R. Okay, I can make those congruence statements. All right, so that's enough information for now. I want you to please start working on investigation 2.1. I will put up an answer key for you so you have that as well. And I think you will be good to go. Thank you for watching. Bye.